In this lesson, we want to review translating phrases into algebraic expressions and equations. So for the majority of you, you've already taken an elementary algebra course, and so you have at least some experience with solving a word problem where you need to set up and solve a linear equation in one variable. So these problems are usually referred to as applications of linear equations, and this is going to be the topic of our current section of the course. So for most students, word problems are extremely challenging, and the reason for this is, in addition to solving an equation, they now have to read through a problem, interpret the problem correctly, and create an equation based on the situation given. Now, one of the roadblocks to success with word problems is being able to understand the phrases that you come across in your word problem. You have to be able to correctly translate those phrases into the required algebraic expressions and equations that are needed to get the correct solution. All right, so we're going to look at some of these phrases and just go into how we can translate them into, again, expressions and equations. We're going to start out today by looking at some common addition phrases. And so first we have for a phrase, more than. So more than is telling us we need to add. So as an example, we have 11 more than a number. Now, anytime I see a number or the number, I can replace it with a variable like x or y or z, whatever you want to use. I'm just going to use x. One strategy is just to kind of line out where you see a number and just put a variable. I'm just going to put x there. And if I read it now, it says 11 more than x. Well, that just means if I had x, I want 11 more than that. So that can be represented with x plus 11, right? This is 11 more than x. Then you have sum of. So the sum of a number and 5. So again, when I see a number, it's going to line that out and put x. Let me kind of change my ink here. So the sum of x and 5, that's just x plus 5. Then next we have total of. So the total of 9 and a number. So let me line this out. And let me put x here. So now we have the total of 9 and x. So that just tells me I have x plus 9, or 9 plus x. So next we have increased by. And then we have, for our example, a number increased by 17. So where I see a number, I'm going to cross that out. Just put x. So if x is increased by 17, it's just x plus 17. Then we have plus. A number plus 2. So again, let's line this out, a number. Let's put x here, and it says x plus 2. That's just x plus 2. Very straightforward. Then lastly, we have added to, and then we see 15 is added to a number. Let me line this out where it says a number. Let me put x here. So 15 is added to x, so we have x plus 15. Okay, so it's very easy when you're working with addition because addition is commutative. The order that you add in does not affect the result. So in this case where we have x plus 11, I could reorder that and say 11 plus x. It doesn't change anything. Same thing here. X plus 5 could be 5 plus x. X plus 9 could be 9 plus x. So on and so forth. So with addition and also multiplication, they're commutative. The order does not matter. With subtraction and division, the order does matter. So we've got to pay closer attention to the way things are worded when we work with subtraction and division. So let's look at an example of some addition phrases. And we have this sample problem here. So if a number is increased by 7, the result is 19. Find the number. So again, if I see something like a number, or if I see the number, I'm just going to replace it with a variable. So I'm going to use x, but again, you can use whatever you want. So I'm just going to put that in each place. And down here, I can even specify that I'm going to let my variable x be equal to the unknown number. Let me make that e a little bit better. Okay, so what am I saying here? If x, let me write that down, is increased by, we know this is a key phrase that means plus. So x plus, we have our number 7. It says the result here is 19. So when you see is in this context here, it means equals, okay? So we're going to put equals here, and then we have 19. So once again, if x is increased by, we have our x here. Increased by, again, means plus. Then we have 7. 7's here. The result is, that means equals. And then we have our 19, so our 19 is here. So we want to find x, and all we need to do is just solve this guy. So I'm going to subtract 7 away from each side of the equation, and that's going to give me that x is equal to 12. And you can read back through the problem and determine if you got the right answer, right? If 12 is increased by 7, the result is 19. Well, yeah, that's true. 12 plus 7, or 12 increased by 7, is 19. So if we want to find the number is just 12. Okay, let's take a look at another one. So if a number is added to 12, the result is negative 11. We want to find the number. So again, if I see a number, or I see the number, I'm just going to replace that with a variable, and I'm going to use x. And again, I can label this down here and just say that we're going to let x be equal to the unknown number, okay, just for clarity. And again, if x, so I'm going to read it like that. So if x is added to 12, so is added to just means plus, so x plus and then 12. The result is, okay, in this context, this means equals. Then we have negative 11, okay? So if x is added to 12, so x plus 12, the result is, or the result equals, negative 11. So that's how we got our equation. Then we want to find x, or find the number. So again, I just want to solve this guy. Let me subtract 12 away from each side of the equation. I would have that x is equal to negative 23, right? And again, reading back through the problem, if negative 23 is added to 12, the result is negative 11. That is true, right? So our number here is negative 23. Okay, this is what we're looking for. All right, let's look at some subtraction phrases. Again, you've got to pay close attention with subtraction because it's not commutative, right? If I have something like 10 minus 5, this is not equal to 5 minus 10. I can't switch the order there like I can with addition. Right? If I had 10 plus 5, that is equal to 5 plus 10. With addition, I can change the order. With subtraction, I cannot. Okay? So one of the phrases is minus. Okay, we all know minus means subtraction. Something like 12 minus a number. So I'm starting with 12, and I'm subtracting away a number. So again, every time I see a number, I can line that out and just put x. So 12 minus x is 12 minus x. Again, if you put x minus 12 there, it's not correct, right? This would be wrong. This would be wrong, okay? So you've got to make sure you go in the correct order. 12 is what I'm starting with, and then minus my variable x, or my unknown number. Then we have less than. So 14 less than a number. Okay, let me line this out and put x here. So again, very important to interpret this correctly. We want 14 less than x. So that means I'm starting with x, and I want 14 less than that, so I'm going to subtract away 14. So this translates into x minus 14, not 14 minus x. Okay. Next, we have less. So a number less 8. Okay. Again, a number, I'm going to cross it out and put x. So x less 8. That means I'm starting with x, and I'm taking away 8 from that. Okay, another one is subtracted from. So again, a number subtracted from 19. So let me line this out and put x. So we have x subtracted from 19. So pay attention there. It's subtracted from 19. So I'm starting with 19, and I'm subtracting away x. Okay, so this is 19 minus x. Then we have decreased by. So a number decreased by 4. So let's line out a number and put x. So if x is decreased by 4, it's just x minus 4. Then we have difference of. So the difference of 5 and a number. So you've got to go in order here. Remember, when we talk about the difference, that's a result of subtraction. So the difference of 5 is going to go first, and a number, let me line this out and put x. The difference of 5 and x would be 5 minus x. If it said the difference of x and 5, that would be x minus 5. So you've got to go in order. Then we have take away. So a number is taken away from 15. So again, for a number, I'm just going to put x. So x is taken away from. Okay, it's taken away from 15. So 15 starts out, and then we take away our x. Okay? So again, with subtraction, the order matters. So you've got to correctly interpret these, otherwise you will not get the right answer. So let's look at some examples. All right, so we have that 4 less than a number is 29. Find the number. So again, wherever I see a number or the number, I'm just going to replace that with a variable. Again, I'm going to use x. And again, for the sake of completeness, I'm just going to say we're going to let x be equal to our unknown number. Okay. So 4 less than x, right? Think about that. That means I have x and I want 4 less than that. So x minus 4. Then we have is. In this context, that means equals, and then 29. So to find the number, I would just add 4 to both sides of the equation, and we get that x is equal to 33. Right? So if I had 4 less than 33, that would be 29. So the number is 33. All right, next we have the difference of a number and 7 is 13. Find the number. So again, where I see a number and the number, I'm just going to replace that with a variable. So we'll use x again. And again, for completeness, I'm just going to say that we're going to let x be equal to our unknown number. Okay, so what can we say here? The difference of, we have x and 7. So the difference of x and 7, x comes first, so we'd have x, and then we have minus, we've got our 7, and then we've got our is, okay, this means equals, and then we have 13. So essentially we have x minus 7 equals 13. To solve this for x, we add 7 to both sides of the equation. We get x is equal to 20. So the difference of 20 and 7 is going to be 13. That's correct, right? 20 minus 7 is 13. So we can say our unknown number here is 20. All right, let's take a look at some multiplication phrases. So we have times. We all know that times means multiplication. So 19 times a number. Again, I can mark out a number and put x. 19 times x is just 19x. Or you can put 19 times x like this, whatever you want to do. Then the product of, we know the product is a result of multiplying 2 or more numbers together. So the product of 11 and a number. So again, we can mark out a number and put x. So the product of 11 and x is, again, just 11 times x. Then multiplied by 4 multiplied by a number. Mark out a number and put x. 4 multiplied by x is 4 times x. And then twice. We know that's like doubling something or multiplying by 2. So twice a number. So if we put twice x, that's just 2 times x. Tripled. A number is tripled. We know if we multiply by 3, we're tripling something. So we can mark out a number and put x. X is tripled. That's 3 times x. And then of, here we have 1/2 of a number. So again, mark out a number and put x. Generally, you're going to use of when you're working with fractions. You want a fractional amount of something. So I want 3/4 of something, 5/6 of something, or in this case, 1/2 of something. So 1/2 of x is 1/2 times x. Now again, with multiplication, it's commutative, right? The order that I multiply in does not affect my result. So let's look at some examples. So when a number is multiplied by 19, the result is negative 266. Find the number. So again, when a number, and here we have the number, I'm going to replace that with x. So let's put an x here, and let's put an x here. And again, for completeness, I'm just going to say let x be equal to my unknown, again, my unknown number. Okay, so when x is multiplied by 19, so that's just 19x, the result is, again, this guy right here is just going to be equals negative 266. So this tells me I have 19x that's equal to negative 266. I can solve this very easily. I can divide both sides by 19. And I'm going to get that x is equal to negative 14. So again, find the number. It's going to be negative 14 because when negative 14 is multiplied by 19, the result is negative 266. That's true. So negative 14 is my unknown number here. All right, now we're saying that 1/2 of a number is 28. Find the number. So again, a number and the number. I'm just going to replace that with a variable like x. So 1/2 of x would just be 1/2 x. And then we're saying is, okay, this is going to be equals. And then we have 28. So find the number. All I've got to do is solve this equation. But let me write this right here and say that we're going to, again, let x be equal to our unknown number. Again, this is just for the sake of completeness. And to multiply both sides by 2 here would give me a solution for my equation. Right? I can multiply this side by 2 and this side by 2. This guy here would cancel. I'd have x is equal to 28 times 2 is going to be 56. So that's my unknown number, right? 1/2 of 56 is 28. That's correct. All right, so we also have some division phrases. We want to remember that division is not commutative. So the order that we divide in is going to change the result, right? So something like divided by, and then we have a number divided by 3. So again, I'm just going to line out a number and put x. If that's divided by 3, we would have x over 3, right? X divided by 3. So essentially, x goes in the numerator, it's your dividend, and 3 goes in the denominator, it's your divisor, right? So x divided by 3 would be x over 3. It would be wrong if you put 3 over x, right? If I put 3 over x, that would be incorrect. So again, the order matters here. Then we have quotient of. So the quotient of a number and 7. I'm just going to line out this part that says a number and put x. So the quotient of x and 7 would be x over 7, okay? Then we have ratio of, the ratio of a number and 20. Again, just going to line out a number and put x. So the ratio of x and 20 would just be x over 20. All right, so let's look at a few problems with division. So we have the quotient of a number and 13 is 18. Find the number. So again, wherever I see a number or the number, I'm just going to replace this with our variable x. And again, for completeness, I'm just going to say down here we want to let x be equal to our unknown number. So the quotient of x and 13, that's just x over 13. Then we have is, right? In this context, it means equals. Then we have 18. So to find the number, let's just solve the equation. We'll multiply both sides by 13. And we'll get what? This cancels. We'll get x is equal to 234. Right? 18 times 13 is 234. So when we say find the number is going to be 234 because the quotient of 234 and 13 is 18. All right, now we have a number divided by 8 is 17. Find the number. So again, for a number or for the number, I'm just going to put my variable x. So x divided by 8. So x divided by 8. Is, again, this means equals. So we have equals, and then we have 17. Again, find the number or find x. So let me write down here that we're going to let x be equal to our unknown number. Again, just for completeness. And so to solve the equation here, I'm just going to multiply both sides by 8. 17 times 8 is 136. So these guys cancel. You get x equals 136. So that's going to be my unknown number. Again, if 136 is divided by 8, the result is 17. Okay, so 136 again is the number. For all the problems we looked at, we used is for equals, but there's other things you can see. So it's basically any phrase that implies sameness. Okay, so some examples would be, again, we use is. So 5 times a number is 7. So again, if you line this out and you put x here, 5 times x is, okay, that is means equals. So 5 times x is or equals 7. Then here, we just have the word equals. So 4 added to a number equals 17. So that's pretty straightforward. Line out your number and put x. 4 added to x, which is x plus 4, equals 17. Then we have is the same as. So a number less 5 is the same as twice the number. So let's line this part out here and put x. Let's line out this part here and put x. So x less 5, that's x minus 5, is the same as. Okay, that's basically us saying equals, right? It's implying sameness. So is the same as is equals. And then we have twice x, so 2 times x. All right, let's go ahead and take a look at 2 examples that kind of tie everything together. And in the next lesson, we'll start looking at some common application problems, again, that deal with linear equations in one variable. So when 2 is multiplied by a number, and then 8 times the sum of 11 multiplied by the number and 1 is subtracted away, the result is the same as -6 times the sum of 10 and 10 times the number. Find the number. So this is a lot more complex than the little simple ones we looked at earlier. We're just kind of putting things together. So let's go through. And again, I'm just going to let x be equal to my unknown number here. So I'm going to highlight everywhere I see a number and just put x there. So everywhere I see a number or the number. So let's read back through. When 2 is multiplied by x, and then 8 times the sum of 11 multiplied by x, and 1 is subtracted away, the result is the same as. So we know this part right here where we say is the same as, that's going to be equals. -6 times the sum of 10 and 10 times, again, for the number, I'm going to put x, and then find the number, I'm going to put x here. All right, so let's read back through this now. So we have when 2 is multiplied by our number x, so I'm going to put 2x. Then we have and then. So and then means afterwards. We have 8 times the sum of. So whenever you have the sum of in this type of problem, you're going to multiply 8 by a set of parentheses, okay, because you're going to have a sum. So I'm going to put 8 out here times a set of parentheses. I don't know what's going to go inside yet, but I'm just going to set that up. So 8 times the sum of, you've got 11 multiplied by our x. So we've got 11x, and then and 1. So and 1. And now it says is subtracted away. So this was subtracted away from our 2x. So let's just read through this part again and make sure we got it. So when 2 is multiplied by x, so we have our 2x, and then 8 times the sum of 11 multiplied by x and 1 is subtracted away. So 8 times the sum of, we have 11x and 1. So 8 times the sum of 11x and 1, that's what we have here. And again, that's subtracted away. So that's why we have minus 8 times the quantity, 11x plus 1. Then we have the result is the same as. So we know this is equals. Then we have -6 times the sum of. So again, I'm going to put -6 here. If I have times the sum of something, I'm going to use parentheses. So then we have 10 and 10 times x. So 10 plus 10x. And this is basically going to be our equation, right? So again, to go through this part again, we have -6 times the sum of. So -6 times the sum of 10 and 10 times x. So -6 times the quantity 10 plus 10x is what that translates to. Okay, let's go ahead and solve this equation. So I'm going to have my 2x here, and then I'm going to distribute the -8 to each term. So you would have minus 88x, and then minus 8. And this equals, I'm going to distribute the -6 to each term. So -60 plus -60x. On the left side, I can clean up because 2x minus 88x would be -86x. Then you have minus 8 is equal to -60 plus -60x, or you can just put -60x, whatever you want to do. Doesn't matter. Let me kind of get some room going here. So let's go ahead and add 60x to each side of the equation. Let's add 8 to each side of the equation. So we know that this is going to cancel here, and this is going to cancel here. -86x plus 60x is -26x. And this equals -60 plus 8 is going to be -52. Now, if I divide both sides of the equation by -26, I'm going to get that x is equal to +2. Okay, so 2 is my unknown number. So let's go back up. Let's write this as our unknown number, and let's check this. So when 2 is multiplied by 2, so 2 times 2 is 4, and then 8 times the sum of 11 multiplied by 2 and 1. So we're going to have 8 multiplied by the sum of 11 times 2, which is 22, and 1. So 22 plus 1 is 23. 23 times 8 is 184. So we'd have 184 here. Now it says that this is subtracted away. So 4 minus 184 is going to be negative 180. And it says the result is the same as. So we're going to put equals here. You've got -6 times the sum of. You've got your 10 and 10 times x. And again, x is 2. So you'd have negative 6 times the sum of, you would have 10 plus, 10 times 2 is 20. So 10 plus 20 is 30. So you'd have negative 6 times 30, which is negative 180. So the same value is on the left as we have on the right. So 2 is our correct solution here, right? That's going to be our unknown number. All right, let's take a look at one more of these. So we have when a number is divided by 4 and then added to 3, the result is the same as 7 less than the sum of the number and 1. Then find the number. So again, wherever I see a number, so where we see a number here, and then the number here, and then the number here, I'm just going to put x in each place. And then again, for completeness, I'm just going to say we're going to let x be equal to our unknown number. Okay? So reading back through now, when x is divided by 4, so that's x over 4, and then added to 3, so then just plus 3, the result is the same as, so that means equals, right? So I can just kind of highlight this where it says is the same as, and I can just put equals there. So this will be equals here. It says 7 less than the sum of x and 1. So we want the sum of x and 1, which is x plus 1. And then we want 7 less than that. So just subtract 7 away from that. And this will be our equation. Okay, so let's copy this. And we'll just come down here to a fresh page so we're not in the way of everything. And what I'm going to do is just kind of clean up first. So I'm going to add 1 and negative 7. 1 plus negative 7 or 1 minus 7 is going to be negative 6. So I would have x over 4 plus 3 equals x minus 6. And I can subtract 3 away from each side of the equation. Kind of make that a little better. And let me go ahead and cancel this. So we have x over 4 is equal to x minus, if we have negative 6 minus another 3, or negative 6 plus negative 3, you're going to get negative 9. So this is x minus 9. And then now I can clear this denominator here by multiplying both sides of the equation by 4. So these would cancel. I just have x on the left. On the right, you'd have 4 times the quantity x minus 9. So that's 4x minus 36. Okay, so to solve this guy for x, what I'm going to do is I'm going to subtract 4x away from each side of the equation. So that's going to cancel. X minus 4x is going to be negative 3x. And this equals negative 36. So now we can divide both sides of the equation by negative 3. And we're going to get that x is equal to 12. So let's go back up. So we're going to say that our unknown number is 12. So 12 here. Okay, so let's check. When 12 is divided by 4, that would give me 3, right? 12 divided by 4 is 3. And then added to 3, so 3 plus 3 would be 6. We say the result is the same as, or equal to, 7 less than the sum of, you'd have x as representing the number, so 12 and 1. So the sum of 12 and 1 is 13. And if I had 7 less than that, I would have 6. So again, same value on the left as you have on the right. So you can say that 12 is in fact the correct solution. That's your unknown number.